Hello dear friends, welcome back again to another video from my YouTube channel. Dear friends, in our previous video we discussed about the development process of monocot embryo, and we have also seen the detailed structure of the monocot embryo in the last video. In this video, we are going to understand one more very important structure which is formed after fertilization, that is nothing but seed. Seed is the most important post-fertilization structure in the angiospermic plants. Now, what is a seed? Let us try to understand some basic things about this seed. Seed get developed by the ovule. Ovule develops into seed after fertilization. After fertilization, ovule develops into seed, and this seed which is present in fruit. Where the seeds are present? Generally, seeds are present inside the fruit. Now, from where this fruit comes? Ovary get converted into fruit after fertilization, whereas ovule get developed or ovule get converted into seed after fertilization. Hence, the scientific definition of seed is nothing but seed is the fertilized ovule. In the same way, we can also define the fruit also. Fruit is the fertilized ovary, whereas seed is the fertilized ovule. This is the scientific definition of the ovule. And this seed, it consists of 4 different components, 4 different parts, 4 different very important structures in it. Let us understand the 4 important structures. Seed consists of the first structure is seed coat. Second structure is cotyledons. Third structure, embryo or embryo axis. And the fourth structure, the seed that consists of, is micropylar pore, micropylar opening. They are the 4 very important components of the seeds. Now, let us understand them one by one in detail. Seed coat, the name itself giving the meaning. It is a jacket of a seed. It is a covering layer of a seed. If you recall the structure of anatropous ovule, the entire anatropous ovule is protected by 2 layers, outer integuments and the inner integuments. After fertilization, these integuments, they get converted into seed coats. Seed coats developed by the integuments. Seed coats developed by the integuments after fertilization. After fertilization, the integuments, outer integument and the inner integument, they get converted into seed coats. Here, there are 2 integuments that we have studied during the anatropous ovule. There are 2 integuments, outer integument and inner integument. Outer integument develop into testa. Outer integument after fertilization get converted into testa, get developed into testa, whereas the inner integument after fertilization, it get developed into tegmen. Inner integument get developed into tegmen, outer integument develop into testa. What is testa? Testa is the outer seed coat. Seed is covered with two coats, seeds are covered with two jackets, seeds are covered with two protective layers. Outer seed coat is called as a testa, which is very hard and tough. Whereas the inner seed coat, it is technically called as tegmen. Tegmen is very soft, very thin layer as compared to the testa. Testa is the outer seed coat, tegmen is the inner seed coat. Testa get developed from the outer integument, tegmen get developed from the inner integument after fertilization. This is the first structure which is present in the seed. Now, the second structure which is present in the seeds are called as cotyledons. We know some of the seeds have got only one cotyledon, and some of the seeds they have got two cotyledons. Some of the seeds they have only one cotyledons, and some of the seeds they have two cotyledons. Based on these cotyledons, based on the number of the cotyledons present in the seeds, seeds can be classified into dicot seeds and the monocot seeds. This classification is completely dependent on the number of presence of cotyledons in a seed. If any seed consisting of only one cotyledon, definitely it is monocot seed. If any seed consisting of two cotyledons, then it is called as dicot. Very simple. Based on this, we have classified the seeds. Then the third structure which is present in the entire seed, the third very important component of the seed is embryo. This embryo is actually the future generation. It is actually the future plant. This embryo get developed into a new plant in future. This embryo consists of plumule and radicle. In our previous video, we made it very clear that what is plumule and what is radicle. Plumule is the mass of cell that in future develops into the shoot system, whereas radicle is a mass of cell, it is a tissue which give rise to the root system after the seed germination. These two structures are present in the embryonal axis or embryo simply. The fourth very important component of the seed is a micropylar pore. Micropylar opening. Pore means opening. Micropylar opening. This micropylar opening, it is present in the seeds. It helps, this opening, it helps in entry. It helps in the entry of oxygen and water. It helps in the entry of oxygen and water during seed germination. When the seed is germination, when the seed is getting germinated, at that time this micropylar opening, it helps in the entry of oxygen as well as water inside the seed, so that the seeds can get germinated and they can produce a new plant in the future. For that purpose, this micropylar opening or micropylar pore is helpful. They are the four very important components. They are the components of seeds. Components of seeds. After understanding the definition, after understanding the components of the seed, now let us talk about the types of the seeds. It is very important for examination. Types of seeds. Scientist has classified there are three different types of the seeds. Let us write here types of seeds. There are three types of seeds given for your syllabus. The first one is non-albuminous non-albuminous seeds. Then the second one is albuminous seeds. And the third type of seed is perispermic seeds. There are three types of seeds given for your syllabus: non-albuminous, albuminous, and perispermic seed. Let us understand one by one in detail. Non-albuminous seeds, they are also called as X-albuminous seeds. They are also called as X-albuminous seeds. Now, what is the definition of X-albuminous seeds? We know inside the seeds we have the embryo is getting developed. During the embryo develop, if the entire endosperm is utilized during the development of embryo inside the seed, if the entire endosperm is consumed, such seeds are called as non-albuminous seeds. What is the definition of non-albuminous seeds? During the development of embryo, if entire endosperm is consumed. What is endosperm? Endosperm is a nutritive tissue that nourishes the developing embryo that we have discussed in our previous videos. During the development of embryo, if the entire endosperm is consumed, such seeds are called non-albuminous seeds. The best example for non-albuminous seeds are peas, pea, groundnuts. They are the examples for non-albuminous seed. Let us recapitulate. Non-albuminous seeds means they are the seeds in which endosperm is absent. In this seed, endosperm is absent. Why the endosperm is absent in the non-albuminous seed? Because it is completely been consumed by the embryo during the development course. Now, albuminous seeds. Albuminous seeds are completely opposite to the non-albuminous seeds. Albuminous seeds means they are the seeds in which endosperm is still there. Such seeds are called as albuminous seeds. Let us define the albuminous seeds. During the development of embryo, if endosperm is not completely consumed. If the endosperm is not completely consumed, such seeds are called albuminous seeds. The best example is for albuminous seeds are maize, jawar, castor. They are the examples. In albuminous seeds, you people can answer this. In albuminous seeds, do we have endosperm left or not? We have the endosperm. In this seed, endosperm is endosperm is present, whereas endosperm is completely absent in case of non-albuminous seeds. Now, the third category of seed is perispermic seeds. Perispermic seeds, they are simply called as, they are also called as perisperms. Perisperms. Perispermic seed, or they are simply referred as perisperms. What is perispermic seed? It is completely different from these two types of seeds. If any seed consisting of the remnant of nucellus, what is that nucellus? Let us recall the structure of anatropous ovule. In that anatropous ovule, we have a nourishing tissue made up of parenchyma cells surrounded to the embryo sac. That is called as nucellus. Nucellus is a nutritive tissue that nourishes the developing embryo sac that we have studied in the previous videos. If any seed consisting of some amount of nucellus in it, such seeds are called as the perispermic seeds. अब जो भी सीड में न्यूसिलस थोड़ा बाकी है, ऐसे सीड्स को हम क्या बोलेंगे? पेरिस्पर्मिक सीड बोलेंगे. अब जो भी सीड के अंदर एंडोस्पर्म थोड़ा प्रेजेंट है, ऐसे सीड को हम क्या बोलेंगे? अल्बुमिनस सीड. जो सीड के अंदर एंडोस्पर्म बिल्कुल भी नहीं है, सारे का सारा एंडोस्पर्म एम्ब्रियो खा के खत्म कर दिया, ऐसे सीड्स को हम क्या बोलेंगे? नॉन अल्बुमिनस सीड्स. लेट अस डिफाइन दिस. द remnant of nucellus in a mature seed is called as the perispermic seed. जो भी सीड में न्यूसिलस है, इसको हम क्या बोलेंगे? पेरिस्पर्मिक सीड. जो भी सीड जिसके अंदर एंडोस्पर्म है, ऐसे सीड्स को हम क्या बोलेंगे? अल्बुमिनस सीड. जो भी सीड जिनके अंदर बिल्कुल भी एंडोस्पर्म नहीं है, ऐसे सीड्स को हम क्या बोलेंगे? नॉन अल्बुमिनस या फिर एक्स अल्बुमिनस सीड. एंड द बेस्ट एग्जाम्पल फॉर this type of seed, perispermic seed, is Piper nigrum. Piper nigrum is the best example. Piper nigrum means black pepper. Black pepper is the best example for perispermic seed. This is about the definition of a seed, components of the seed, and the 3 different types of the seeds given for your syllabus. In our next video, we are going to discuss about the advantages of the seed and the very important quality of the seed, the very important characteristic feature of the seed, that is called as a seed dormancy. We'll discuss seed dormancy as well as the advantages of seed in our next video. Thank you so much.